Hello and welcome to this SAP Tech Bytes video. In this particular video, we want to take a look at the SAP Cloud Application Programming Model Consuming Remote Services demo from the SAP TechEd 2021 Developer Keynote. And this is an opportunity for us to look at the short demo that was less than 4 minutes when it was delivered during the keynote in much greater detail. Go behind the scenes of how some of the things worked, uh, things like authentication that we had to kind of gloss over in order to fit it into the time of a keynote. We're able to go into much more detail here in this expanded director's cut version of the demo. Now, the background is the same as when we talked in the developer keynote, that often the SAP Cloud Application Programming Model samples and other content, we really focus on the ability to model and create OData services. But the Cloud Application Programming Model also has some amazing functionality to help you with consumption of services from other systems, or to create a mashup of local data and remote data fetched via a single service call. And that's exactly what we want to do here today. Is we want to see how to take a SuccessFactors OData v2 service, how to pull that into our CAP service to be able to call it remotely, and to enhance it with some additional data fields that we will model and persist only in our CAP extension project. And then finally, some of the things that we didn't show in the original developer keynote is we want to show newer capabilities of the cloud application programming model to also expose your service endpoint as OData v2, as GraphQL, and as plain REST. So let's go ahead and jump into things now and have a look at how this demo was built. Just like in the original keynote demo, we're going to need to start by finding the details of the external API that we want to call. And in this demo scenario, we want to consume a SuccessFactors personal information API and then add some of our own fields to the new service. And those new fields will only be persisted locally in our Cloud Application Programming Model extension application. So we won't be sending all the new fields data back to SuccessFactors, but combining it with data from SuccessFactors and data that will persist locally. Now, like with any API-based application or extension, to begin, we're going to go to the SAP API Business Hub. And here I am in the start page of the API Business Hub. Now I want to go ahead and be sure to log on here. That way I'm going to be able to get my API key, which we're going to need to process the service call. So once you are logged in, you can come up to Settings, and you can click this button and it will show you your API key. I'm not going to bring that up right now, but later I'll show you in our Cloud Application Programming Model project where we're going to use that API key in order to test in non-productive scenarios with the API Hub. But once you've grabbed that API key, then we need to find our specific API. So we're going to want to go to the SuccessFactors section of the API Hub. Let me just go to APIs. And we are looking for the personal information API. That's what we need to use to extend in this particular situation. So I'm just going to type in personal. There it is, personal information. We can see the technical details that it is an OData v2 API. And if we go ahead and click on that, we can see the API reference. We can try it out from here as well. So maybe you want to test it, in the sandbox environment. Go ahead and run that, and you can see some of the results that you'll get back calling this API. But what we're going to need to start doing our work is we're going to have to come back over here to the API reference, actually to the overview, and go to the API specification. And we want to download the EDMX file. That's what we're going to need in our to import into our Cloud Application Programming Model project in order to bring in the definition of this API. So we'll just go ahead and download that so that we've got it locally. And that's all we really need from here. Of course, you could read more technical information about what's supported by this particular API. Um, Link over to help.sap.com to get more details about it. But we have what we need in order to import it into our CAP project. So now I've returned to my development environment, which in this demo, I'm using Visual Studio Code for local development. But basically, you could do all these same steps in the very same manner using the SAP Business Application Studio as well. And it's nice that we have our choice of environments that we want to work in there. Now, what I want to do is I want to start by creating a new SAP Cloud Application Programming Model project. So I'll just open the command palette and then open the template wizard. And you see some of the SAP project templates that are available on a database development, Fiori development, generic multi-target application generator. But the one that we want is the SAP Cloud Application Programming Model. So we'll just go ahead and choose that as our project type. Now we'll give it a project name. I'm going to start off here. Let's just say extension. Doesn't really matter what you name your project. I'm going to go ahead and put a CI/CD pipeline in there. We can add HANA configuration later, but for now, we're just going to do local testing with the SQLite database. I'm going to do a MTA-based deployment project. And I'm going to go ahead and have it generate some sample files, just in case we need to quickly prototype something, but we're not necessarily going to use those sample files. We'll pretty quickly be adding our own stuff here. So let's just go ahead and finish and let the project generate and reopen. And what we see here is we have a new workspace with this project, and it's added configuration for potentially a user interface, database development, service layer development, service enablement, and it has put the bookshop sample content out here of both an entity to define ultimately a database table and a no data service exposed from there. Like I said, we're not going to use this bookshop stuff. We'll get rid of it here in a minute, but it lets us kind of show you what you would get there. And no, I don't need the recommendations. Everything else is ready to go. So now we want to import the OData service definition into our CAP project, and there is a CDS command line tool that will help us do that. So let me just open a new terminal here. Now, if I just use the CDS import command and then give it the location of where I just downloaded that EDMX file, and it was EC person EDMX, and we'll just execute the CDS import command. And we see that it has imported the API definition, stored it in the SRV external folder, and then it also updated our package.json file. So let's see what all it added here. If we go into SRV, we now have an external folder, and now we've got the service definition in CSON format, this CSN file. And that's a process that the Cloud Application Programming Model can process internally. So that's otherwise known as schema notation. We also see that it has altered the package.json file, which already had some of the basic cloud application programming model dependencies in it. But now we see that it's added a section here for CDS requires and named the service. You see personal information. It's denoting that that is an OData v2 service and where to go get the model definition of that service. So we've added that external service to our project, but that's kind of where the import is ended. It hasn't adjusted our CDS definition files. It hasn't added it as an entity because it doesn't know what we want to do with it. Do we just want to call it? Do we want to create a mashup of it and combine it with some local data? And that's precisely what we want to do. We want to create a mashup. So what I want to do now is I'm actually going to switch over to my sort of already finished version of the project rather than do a lot of typing. But I'm going to walk you through all the manual changes that I did to further use this service and then re-expose it as a CAP service, but with extended fields on it. So I've switched now to the final version of my project, and this is actually the version that's available in the SAP samples repository on GitHub. So if you want to check it out directly, try it on your own local machine, you can go ahead and pull this down, and everything that I'm going to show you here is pretty much available. Now, the changes that I've made to make this work beyond what we've seen so far, which is just the project creation and then the importing of the external service. There's a couple of changes, or additions, I should say. First of all, in the package JSON, I've added a couple of other optional features that I'll show you later. By default, the cloud application programming model is going to create an OData v2 an OData v4 service. And it's pretty neat because we're calling an OData v2 service, if you remember what we saw in API Hub. But then when we re-expose that with our extended version, the cloud application programming model will automatically convert that to OData v4 and do all the translation in between. We'll see that in a minute, how simple it is to call the OData service from within CAP. But I've added a couple of other things. I added the OData v2 proxy. So if we also, from our single endpoint, we also want to expose OData v2, we can do that. I also added a couple optional dependencies here for GraphQL. You see the GraphQL tools, Express GraphQL, and GraphQL module there. Now, this is an experimental feature that became available in the November 2021 release of the Cloud Application Programming Model, but I'll also show you how easy that is to add in and expose to your expose as part of your service as well. I added a .env module. We'll see that in a minute. That's going to help with loading our API key. And then I added a cores module so that if we want to configure cores, cross-origin scripting, particularly useful because I know later the service is going to be consumed by AppGyver, and we need to configure cores for us to be able to access our service from AppGyver. So I added a couple of other dependencies. I did do an npm install as well. So, I've got a full node modules folder. You want to be sure, even after the project generation, you should do an npm install to bring down all the dependencies. The other thing that I did is I extended the CDS configuration section. Now, some of this you don't need. Some of it is just setting the version of the UI5 preview tool that you get when you test in Cloud Application Programming Model. Some are some of the optional features. I wanted to turn on GraphQL or the new REST adapter. I'm just kind of showcasing and showing off some of the newer features of CAP here by configuring and turning them on. But the part that's really, I think, interesting compared to what the initial wizard created, if you remember when we did the CDS import, it created the EC personal information section for us of kind OData v2, and it pointed to the model. And that was it. There were no credentials provided. And we need to provide some credentials and technical configuration of where to go call that service. The EDMX that we imported has the definition of the service, its interface. It doesn't have the technical information about how we need to connect to it. So that's what I've added here, and I've added two different configuration sections. And this is a neat feature that I can configure a completely different set of credentials when I'm working in a development environment than when I deploy to production. And this way I don't have to have two sets of the package.json or remember to change it. I can define both. And when I deploy to Cloud Foundry or Kima, it's automatically going to use the production version. And if it is the production version, then I'm going to use a destination. So when I connect to the service by specifying, configuring here credentials destination, and then this is going to be a SAP BTP destination, and it's only in the destination that I can configure all the technical information about how to connect and what authentication to use and things like that. Now, for development purposes, I want to connect to the API hub, and I want to use the sandbox. And if you remember, if we went back to the API hub when we were in like the try it out, we could get the environment sandbox details, and we could get our API key. That's what we're going to need to be able to call it from the API hub. And that's what I've configured here is a URL to the API hub and telling it to use no authentication because it's going to use the API key as our authentication. So that's what I needed to extend in the package.json. Now, what do I need to extend elsewhere? If we look at the database, the data model, I actually have not done anything with that. I've left it as is with just the original sample bookshop. I could take that out. I'm not using it, but just to show you that I've done nothing at the data model level. I've only come into the service level, and I've come here and I've created a service file to define my OData service that I want to expose out of my application. I've called it catalog service. But now I'm saying that I'm using EC personal information from, and I'm pointing it to that CSON file that was created via the CDS import. So normally, when you're creating a service file in CAP, you would point to your data model, and you would import the entity definitions from your data model. But here, I'm importing my entity definitions from that external, that CDS import. So now I've got this EC personal information. I have an entity in my Cloud Application Programming Model application called external. A host service definition called external that I've imported. Now, what I want to do is I want to create a new entity, and I want it to be a projection on the external service. So I'm going to take the service definition, and I'm going to say I want a projection on it, and I'm going to limit it down. It had a whole bunch of columns, but maybe as part of the simplification of my particular service, I only want a subset. I want first name, last name. Instead of initials, that was the column name inside the original service. I'm going to rename that as name header. So you see here title as personal title. So not only do you have the ability to reduce the service, but also to change the names of the attributes or the columns exposed by the service. And then finally, with this ... a constant, as middle name type string, well, I'm extending the entity. I'm adding a whole nother column that was never there in the original service definition. I'm adding a middle name. And what I'm telling it to do here is I'm actually telling it, yes, I do want to persist this in my local in my extension itself. Normally, an entity that is a projection would not be persisted as a table. Here, I'm going to persist it as a table so that I can store the key values and this middle name. but not store all the other data, so that I'm able to do a mashup and combine data from the remote service with locally persisted data. Now you might see here that I've also taken this existing service, the per personal, that's my extended service, right? Catalog service per personal, and I've re-exposed it as another projection called per personal, but with a different service endpoint, catalog service rest. And I've used the at protocol to also expose a pure REST version of the service endpoint. So right now, with this service definition, I've got OData v4 and I've got a pure REST version of the service. So that's my model to create the mashup service. But now I need a couple pieces of code. So the generic handlers of the cloud application programming model don't know how to combine my local data with my remote data. I do have to code that myself. In order to make that work, I'm going to need a couple things. First of all, I'm going to need a server.js. Now that's the bootstrap of the whole cloud application programming model service. It allows me to code on startup of the entire service. And for the most part, this is where I'm adding extra things, like I'm adding the OData v2 proxy. That will automatically create an OData v2 version of my service as well. This is where I'm adding the cores, the cross-origin scripting support. I'm also adding a health check. But probably the most important thing, I mean, you could leave all these things out. They would all be optional features. But what I have here, though, is in a non-production environment, I'm also using this .env module to load configuration. And all that's going to do is it's going to look for a .env file, which you're not going to find in GitHub, because all it has in it is my API key, which I've blurred out here because I don't want to give out my API key. You would go to the API hub to look up your own API key. If you create a .env file and put an entry in here for API key and put your own API key in here, what that's going to do is it's automatically going to load that into the environment. And then in a second, you'll see we're going to use that when we make our service call. But this will only be processed in a non-production environment. If this was in production, it wouldn't load that because we wouldn't have an API key as part of our project. We only have that for local testing. .env is excluded from my via my git ignore, so it's not pushed to Git, and it's never part of my project downstream. It's only locally. The next part, and this is the most important part, is to create a custom service handler for when the read operation is requested for our per personal entity. And this is like an exit. It lets us code what happens instead of the generic event handlers. We code and we control what all is going to happen here. And that's going to allow us to both make the external call to the success factor system, then take the resulting data and combine it with our local persisted data as well. Now, what we have here in the read operation, we just have to start off, and we have to build the query, basically, that we want to forward. And we can do that by simply taking the select statement that was already passed in by the generic handler. It's the generic handler of the cloud application programming model is still processing the OData or REST or GraphQL request, and it's taking it apart and it's formulating this into an internal query structure. So we're able to use the request query, and it's select from statement, it's select limit, it's select where, and it's order by. And the cloud application programming model is doing the translation between the column names that we renamed and the original column names. It's doing all that work for us. All we have to do is assemble the query as a new select statement using the pieces of the original generated select statement. But then instead of processing that against the original entity, we're able to send that to the remote system simply by also declaring our EC personal information, which is this connect to EC personal information. That's going back to the package.json and looking up the definition and the connection information and connecting us to the remote service. We're then able to send the request that we built manually and there's our query that we sent through, and we can add headers to it, and this is where we're adding the API key. Once again, we'll only have this API key in our environment if it's in a .env file and it got loaded by the bootstrap, but it only does that in a non-production environment. Otherwise, this would be null, and then we wouldn't be passing an API key. Once again, that's only needed when you are calling via calling to the API hub. So we're going to get the data back. So now we have an array of data returned. We don't have to worry about the fact that it's OData that's been translated back to a simple array of data. Either that or a single record if it was a single get operation. But then what we're able to do next is I want to mass load from the local persistence in my cloud application programming model application the additional data, the middle name. So what I'm going to do is I'm going to write a little mapping function so that this can execute for every record that we got back. And what we're saying is here, for every item that gets passed into this function, take the ID and form a select from the local table per personal, where the ID is equal to the ID of the record that we got returned from the external service. And as long as we got some data back, then go ahead and take the middle name from the local data and add it into the data set that is returned from the external service. And when we've built this mapping function, then we can just say await promise all, get extension data. And what that's going to do is for every record in our on our personals, it's going to perform this operation. It's going to do that one record at a time. It's going to parallelize that, but it won't move on to the next statement until all the records are done. And that's what this promise all gets us. So we get a very efficient, high-speed request of data in parallel there. And you can see, we're able to use select statements for both our external query to the remote service and for querying the local entity. And that's part of the beauty of the cloud application programming model is we use its built-in query language, which is very SQL-like. We'll select and update and delete statements. We don't have to worry about translating between different communication protocols. And then finally, I've got a little hack here. Unfortunately, with the way this mashup approach works, we don't get a select count automatically filled. And therefore, Fiori UI has used that select count for this table pagination. So we need to fill in that select count ourselves. So I do a little calculation here to return the select count. And that's it as far as the custom logic. With this logic, we would now have a service that returns remote data mashed up with our local data. Now, the only thing that I might point out here is that I'm able to mock the data as well. My local data, for testing purposes, I can just create a CSV file with the name of the catalog service and the entity per personal, and I'm able to mock up some middle names. So I don't have to have a connection to a database and pre-fill it with any data or anything like that. I can go ahead and test whether my mocked up service will work or not just by mocking this data with the CSV file, and the cloud application programming model will expose that automatically. So let's test all this put together now. Let's just do an npm start, and that will run our start script. Oh, no, I'm not in the right folder. Sorry. Switch to the cat folder. Oh, no, switch to the section folder and then the cat folder. There we are. Now I'm in the right folder. And now let's do an npm start. And what we see, CDS serve with mocks. That means it will load our CSV files automatically and mock any entities that it finds CSV files for. We see that it is loading the bootstrap from server.js. We see that the OData v2 proxy is working, and that we'll also have an OData v2 version of our service running at /v2. We see that it has loaded our external model and our local models. that is going to be using bindings from CDS service JSON. So that's our configuration to our endpoints. It's running right now just local testing with SQLite, so it hasn't had to connect to a remote HANA database for the local persistence. We see that we've made a successful connection to the EC personal information, the OData v2 service that's running on the sandbox. So we've connected to it. And we're also exposing the catalog service at /catalog. That's our OData v4 service. We're exposing the REST service at catalog service REST. That was the second one that we had there. And they're both using the same custom implementation exit. And that we're serving GraphQL at the endpoint /GraphQL. If we want to test this, we can just go ahead here and click on localhost port 4004. That's where everything's running. And what we see here is we've got a couple different endpoints. Let's test our OData v4 endpoint first. So we can look at the metadata of our mashed up service. There we are, OData v4. There's our service definition and any additional annotations and supporting information of the service. Now we could also come here and we could add v2. And now we have our OData version 2 metadata exposed. So without needing a second service definition or a second service endpoint, our single cloud application programming model application can expose OData v2 and OData v4. It's the same mashup, it's the same exits, it all works the same way. Now let's test this. Let's just go ahead and run our per personal. This is our extended mashup. There we are. It's loaded all the data from the remote service, and that we see for some of the records, the middle name, it's added our data that we persisted here in the CSV file. So like for record number 100009, we said the middle name was test, and there we see in our final service endpoint, all of this data, start date, first name, last name, ID, name header, personal title, that all came from the remote service. We've got just the reduced set of fields. We've got the renamed attributes. But then finally, we have our extended column as well. And it's using the data from our local persistence. We see the same thing here with George, Sally, Luke, Sue, and Henry. But then the rest of the records, there is no middle name because we only persisted in a handful of records. And we've got the full OData capabilities here. You know, if I want to do a top count, so only give me the top 11 records and check to make sure that our special logic to return count, we now see OData count 11, and we only have the top 11 records. So whatever OData v4 parameters you would test with are all being processed and forwarded to the OData v2 service that's behind this. And CAP, once again, is taking care of all the translation there. Now, if we go back and we just change this endpoint to v2 catalog, and now we have an OData v2 service, still calling the remote service, still processing the same exit. We didn't have to write the exit multiple times, but now formatting the output according to OData v2. So we support both of those from the same service endpoint. And likewise, we would be able, let's go back here, show you some other fun stuff. Of course, you have the Fiori preview. This is running against the OData v4 service. And here we see it basically loading the same set of data. There's our, let me make that a little bigger, there's our set of results. And we could drill in and look at one of the records. There we are. So the Fiori preview that's built into the Cloud Application Programming Model test framework there, showing us our service. But we could also test the REST version of our service. So if I click on the per personal that is part of the REST service, it's doing all the same thing, except now it's not OData that's coming back. So we don't have the extra OData metadata or the extra little bit of header information in the result is just a pure REST endpoint now. Same exits are being processed, as you can see here, same remote service call. So now we've taken our remote SuccessFactors OData v2 service and we've re-exposed it as plain REST. Likewise, we added the OpenAPI functionality here. So this is, once again, our OData v4 service, but we've got an entity data model, and we can use the test tool, the Swagger OpenAPI test tool, to also test our service, our new service, our mashup service here as well. Very similar to the tooling that we had in the API Hub to test the original service, except we're now testing our live cap mashup service. And then finally, the last thing that I would show you, come back here, is we have an endpoint for GraphQL. And from here, we have the ability to write GraphQL queries. It's got nice code completion here of the service endpoints, the service entities, and the various columns here. Come here, like do another line. You see all the columns exposed, and we can go ahead and run that query. And there we are. It has now this is still experimental support for GraphQL. It's not finished. It's not perfect. And you notice like my top two actually didn't get passed through for some reason, but it's still executing our exit. And this really shows the power of this. With one exit, we're able to take the input from either GraphQL, REST, OData v2, or OData v4, take CAP processes out all the query parameters, gives them to our code. Our code forwards that to the source OData v2 service. We don't have to do any translation, manipulation for the different protocols. And likewise, we give it the results back. We get the result data, we enhance it with our local columns. We don't have to turn it back into GraphQL, REST, OData v2, OData v4. Cloud Application Programming Model is taking care of that for us. I hope that you've enjoyed this expanded look at the SAP Cloud Application Programming Model Consuming Remote Services demo that was originally presented as part of TechEd 2021 in the Developer Keynote. We've had a chance to go into much greater detail in the demo here today, and I hope it's given you some pieces that you could build upon in your own journey using the SAP Cloud Application Programming Model.